start on the advanced Kotlin testing. So this one is actually the third part of advanced Kotlin of the testings. So there are basically 3 collabs in this session. We're going to go through the third one, but I'll just briefly go through the first 2 as well. So back to my notes. So the first part is actually just setting up to test using the first one is just to set up testing using view model and live data. And to test view model, you use observe forever, and then it needs to run in this instant task execution rule. So the first collab was pretty short and easy. And the second part, part 2, is actually going through the concept of test doubles. So test doubles is what we use in tests that resemble the actual working system, but in different ways that helps you test your things. So there are fakes, mocks, dummies, and other concepts that is listed in here in the testing strategies and things like that. Yes. So for example, it went through like how to make a fake data source and then how to use a fake repository, and actually how do you make your app into a state where you can actually use your fake in your test, but the real thing in your like production app is basically setting up using a service locator. It didn't go through like full data injection using like Hilt. That is actually covered in a previous collab. I encourage you to try that out as well. But for say your existing pet project that you just like whip up in an afternoon, you can follow the steps here to introduce an interface and then use a service locator to say in your actual app, the service locator creates the real implementation, but use that to satisfy the interface that is defined in your consuming classes and things like that. And it goes through like how to run your app in a test with the fake repository hooking up to the real view model and drive the real UI and test basically the integration using Espresso. So I think this lab is very interesting and very valuable. So to be honest, we probably should run this run this lab as well. But since I don't really have like time to go through, because this one took me like more than an hour to follow it, like step by step. So I strongly encourage you to do do part 2 before you do part 3. So let's jump into part 3, where we're for the previous session. I only have the Hilt one on our GDG Seattle YouTube channel because I forgot to record the second one last time. And also, part 1 and part 2 were not done as part of this StudyJam. I strongly encourage you to try this out yourself. The link will be available from the collab link that I just shared. Basically, you see in not here, sorry, but in this one, 5.3, it actually have links to 5.1 and 5.2. However, if you land in this advanced Android in Kotlin collab landing page, here's this thing. The testing one have 5.3 as TBD. So you actually can't find 5.3 here. So that's the caveat. And I'll make sure I update the meetup link and YouTube link to point to the right collab URL. But you should have this URL in the chat, and feel free to follow along. So on the first step, it will basically just say what you should know. You should have done 5.1 and 5.2. And then you should know the basics of coroutines and also view model scope and application architecture. This one is also quite useful in how you should organize your app to basically have a repository, and then that serves the need of the view model. View model then controls your UI with the right state and how to control it. So if you're not familiar, I encourage you to like read through them and also like run through the two collabs before this will also be very useful. And what you'll learn is how to test coroutines, test room, test data binding, and also test global navigation. So that's a lot of things to go through. So let's just jump in. I'm going to basically run the app in the emulator, but it is a to-do app, and you will be writing tests to test its functionality. In here, if you clone the starter code, well, so if you want to clone the code, use git clone to clone Android testing, and then check out end collab 2 branch. So this branch is basically the end of 5.2 and the start of 5.3. And so that's what we will be using in the collabs. So I'm going to switch to Android Studio, and please follow along on the browser for the text note. Start presenting window Android testing. So here we are on this branch, which is my branch when I finish Colab 2. I might just switch to Colab 3 when I'm stuck, but bear with me. So let's run the app. Run the app. And it is just a to-do app, and it should just run, hopefully. And if you read the source code, not source code, but if you read the web page, it will just say like how it works and then how the sample app is organized. So basically, somehow my Gradle is taking its time. So okay, it's showing up, and here is the to-do app, and you have this task list, and then it's backed by the task view model, and it uses live data to talk to tasks repository or the default task repository. And the default repository you have two data sources. One is remote, one is local. And yeah, that's basically what we will be testing. Uh, and the code is organized in a way that has both test in Java or test that runs on JVM, and also test that runs on an emulator or on a device. So these are integration tests under Android test, and these are JVM tests under test folders. The other organization is the app have different layers. So data layer, and then tasks, and then there's also a navigation stack that is defined in the navigation graph under XML here, navigation XML. So that's the navigation graph. That is the navigation component. We also did a collab on that, but unfortunately back then I didn't have any recordings, so have to run it yourself. Next, on step 3, so introduction and review of testing coroutines. We'll just we'll just skip it. You can read it on your own, but it's basically for coroutines that are supposed to running in parallel. In our test, we want to run them in a serial or more deterministic fashion. And that's why we will use run blocking test or run blocking instead of just launch and execute to control the flow of the program. And for JVM tests, or in the documentation, it's referring them to be local tests, then we will use something called a test coroutine dispatcher. That is basically like an analogy in RxJava is the trampoline dispatcher or scheduler, something like that. That is basically you can control like one step at a time, like control time and going forward, backward in time, things like that. So step 1 of this step 3 in this collab is observe how to run basic coroutine tests. So in our build.gradle file, we need to add test dependencies. So here, let's see. That's the Android instrumentation test. So here are local JUnit test dependencies. Uh, Actually, it wants us to import that in. So we want JetBrains Kotlin X Kotlin coroutine test. Yep. So we have that in the build.gradle already, and then we want to look at task detail fragment test. So this is actually a instrumentation test here, and in active task detail displayed in UI. So it says, look here for run blocking test. And we need to annotate this thing with experimental API. So I'm going to just, not here, but in the class itself, because we'll use run blocking test all over the place in this. So yeah, so just annotate with the experimental on top and continue. Um, Also, the tests are, it says, so wrap the code calling suspend function with run blocking test. So there are two, yeah. So basically, if I remove run blocking, then this save task will have error because it is actually a suspend function. Now, you can also wrap it in run blocking, which will also let you run the suspend function, but run blocking will not give you the control like run blocking test does. That is basically how you control the right dispatcher to use in your tests. So run blocking tests also have ability to say, if I have delay function called here. So delay is coroutine's equivalent of thread.sleep in Java. But this is delay in coroutines is a suspend function. So it means when you call delay, the function will cease control and just go to the background. And once the time, say 1000 millisecond pass, it will then regain control. So it's a more efficient way of using CPU cycle than like lazy sleep. And that can be skipped in this run blocking test by say like going forward, going backwards. So run blocking test provides a lot of convenient ways to run your test more efficiently. So let's see. Observe run blocking in test doubles. So there's another function run blocking. So that is used in the fake test repository. Let's see. Where is my fake test repository? So it's probably here. Yes.
I was just going to say it's in the data.source package that you just found it. Yeah.
There are actually two of them. So one
Well,
is
one's the test, and then one's the source, right?
I think there are two of
two
them.
Tests.
Yes, and there's also two copies of the fake repository in the implementation. So one is for Android test, one is for JVM test. Yeah, the one they want us to see is in probably this one. So here in observe tasks, it's using run blocking because refresh task is a suspend function. So in this test repository, we want to ensure it is actually like, how should I say? We want to ensure refresh task is called and actually to complete before we return the observe task in the test. So that's why we're calling it using like run blocking. Otherwise, we can just use use the view model scope or a scope.launch and call refresh, and then we can assemble the live data and send it back there. So the documentation or the website then goes to just say run blocking versus run blocking test. And I think I went through this already. So let's move on to step 4. So we are going to actually learn how to test view models that use coroutines. You might have a long-running task for a view model. So normally you create a new coroutine scope that's tied to the view model. And the lifecycle view model KTX actually give you extension function to provide scope from the view model without you having to like create and do stuff. So step 1, observe dispatcher.main causing an error. So we want to go to task view model task. And that should be in under Java, right? Here, task view model task. And in there, there's a complete task. Actually, no, they want us to add a new test method called complete task and snack bar updated. So let's run this test. On Windows and Linux is Control-Shift-F10. And it come back with an error. What is the error? Don't resolve. Oh, okay. That's my bad. Let's run the test again. Ooh, an error. Main dispatcher failed to initialize. Okay, why is that? Because we are in a JVM test that doesn't give you access to main looper. So I suppose the solution is turn this into a roboelectric test. No, it actually want us to replace dispatcher main with test coroutine dispatcher. Okay, so that's another solution. So what we want to do is copy paste a lot of more code. So again, external API test coroutine dispatcher. So we want to basically import this function called set main and also reset main. So what they do is actually they replace the main dispatcher that is used by Kotlin with any dispatcher of your choice. So basically, it changed the main dispatcher from the default one to a new one. In this case, it's just a test coroutine dispatcher. So now the test pass. Cool. So step 3 of step 4 is add main coroutine rule. So if you're using coroutine in your app, local test involve calling. So basically, it's changing this into a JUnit rule that does the setup automatically for you. So we want to create a new function here, I suppose. Let's call it main coroutine rule. It's a Kotlin file, sure, edit, and we'll just do this. So all the imports, test watcher is a JUnit rule, and let's see, should be JUnit runner, and then dispatchers, and set main, reset main. So basically, starting is like the before annotated function, finish is the after annotated function. So now we can go back to the test and just remove these and create another rule that is the let's see, main coroutine rule, and it also needs the experimental API. So let's run this test again. It still passes. Cool, because this rule sets up the main dispatcher to become the test coroutine dispatcher. Now we want to use that rule for repository testing as well. So in the default test repository test, let's see, in the default test repository, it has this IO dispatcher, right? So we want to say, let's see. So the doc says it's passing a local one. Well, yes, an IO dispatcher, and we also want to, but in our test we actually want to pass a different one. So we want to add the rule to the test. So again, copy paste and import, import, import. So in theory, the main dispatcher is now the test coroutine dispatcher. And in here, when we create, instead of unconfined, we'll just say main. Although in my day job, we will usually just specify test coroutine test coroutine scope and test coroutine dispatcher. But well, I mean, you have the main rule, and so using it there should be fine too. So let's run the test, see if it's working. So it's still working. And one more thing to do is here in the run blocking test, we want to make sure it is blocking on the test dispatcher. So in here, we're using the main coroutine rule. So I think we can just do it like this, and the test will surely be utilizing the test coroutine dispatcher there. So what else? It still works. Cool. So that's step 4. Now to next step 5, testing coroutine timing. In this step, you'll use the pause dispatcher, resume dispatcher, because the test is quite interesting. So there is a statistics module that is something like in your app. So if we say show statistics, right now tests are none of them are complete. So if I complete one, it just gotta be a bug. Now it shows 50-50. But how do you write test for this? Let's see. Before, let's see. So the step first is actually open that new model here, and they want us to replace. Oh, okay. So this is replacing the Android view model with something we can inject. Sorry about that. So instead of application, we want to actually inject the repository. And then we also don't want Android view model, but just a regular view model. And remove this one. And we will create a factory called stats model factory that let us basically inject the repository into the model. Then in the stats fragment, here it's using this, but we now actually want to say use the factory and provide the factory with the right context or with the right as a to-do app. So this is basically the service locator that we created in part 2 of the collab that turns to-do app to provide a task repository using this service locator. Before it was all hard-coded and you just can't change it. Now with this, we will be able to actually swap it. But let's see, let's continue. So we'll create a status view model test, and the test should be somewhere. But let's see. So the step in the previous collab when creating tests is right-click on the class and say generate or like use generate and then create test. Or if you want keyboard shortcut, it's like on Windows, it's Alt Enter and say create test. Now you will be shown with this create test dialog and select JUnit 4 and hit OK. I think we want the test to be under the test source set and just edit. I'll remove those imports there and just continue. So we want to add the task executor rule and basically just copy paste everything from the code. So import, import, import the main coroutine rule. And we want to have fake, let's see, fake task repository. Oh, yeah, this is one thing I didn't do correctly in my collab is I named it wrong. It should be fake test repository, but I just named it fake test repository. So anyway, fake test repository. So what we're doing here is say we will create a view model with this test repository, and that will be the repository we use during the test. So let's see. It says what we want to test is this refresh function. But the organization of this is it calls refresh and sets loading value to false. And how would you test this? They first provide you a naive way of testing this, but as you can see, it is contradictory to one another. So not truth, but I think it's using Hemcrest. Not that one, Hemcrest. So I don't think this will work because you are asserting it to be true and then false immediately after. Like, so this is just not going to run. So next one, um, it just goes through like where do we really want to test the code is we want to test it. We want an assert here. We also want another assert here. Excuse me. And so in theory, we want a way to basically pause before we launch the refresh and assert there, and we should resume and then assert another value here. So we can basically use the pause and resume dispatcher in our test. So say main coroutine rule, pause dispatcher. Let's see, we need the experimental thing again. And then we call refresh, but it's paused, so the code is not executing. And then once we assert the value to be true, then we resume the dispatcher, so it continues. And in theory, we should be able to assert the value after the execution. It's still not working because I did something wrong here. So not refresh tasks, but it should be refreshed. Oh, I should be calling get tasks, right? Let me check my solution. Compare with French. So really? My God, I must be. Oops. Sorry. Oh, test routine timing. Uh, let's see. Yeah, there's something wrong here. I think it's this. No. Oh, so let's see. Go back to model test. Nope. I'm sorry. Live coding. So this thingy is, yeah, I'm going to cheat by looking at the actual Colab, the solution. Where am I? Not the starter code and Colab 3 source in test and in data source, like test repository. So it should be refresh test. And oh, So refresh tasks. What? What am I doing? It's correct. And then serve task, get task. Ah, so I see why I did wrong. So it should really be that, and it should just call get tasks, and let's see if it runs again. Nope. You know what? I'm going to give up. And in theory, the test should just pause the code in the right place, and then once you resume, it should call it in the right place. So that's end of step 5. Sorry about the hiccups. And next is testing error handling. So we want to add an error flag to the test double. That's for the not so happy test, I suppose. So we want to change the task repository to have an error. So we need to annotate this with should show an error. Okay, goes false, and then we also want to expose a setter, and then in all the functions, like get tasks, single task. Where is get task here? We want to say return error, and otherwise return success. So this should really be result.error. That's for the get task, and then get tasks function should also have should show error, and that should also be result.error, and otherwise return success of value to list. Okay, so we want to write a test that returned an error. So in the stats model, there are two view models, but not two live data. One is error, one is empty. So if it's error, then it will emit an error. So what we want to test is test when it errors out. So in the view model test, we want to add one more test that basically set it to return an error, and we want to see the value to like show something that's wrong. And again, my repository is is really not happy. So refresh tasks. Oh, so okay. So my problem is I returned the wrong type in here. So yeah. Um, so okay. So the fail case worked. Let's see if the heavy pass also works. So yes, so both tests works now, and we can finish step 6. And on to step 7, we want to test room. So room is the database layer above SQLite that the Android team provides. So let's see, we want to have core testing as part of the build.gradle. So Android test implementation, do we have core testing? That's in test implementation. We also want that in the Android test implementation. So we'll just add it here and let Gradle sync for a second. but then we want to create a test del test. So that should be in AdvancedTest. And then we want to have data source here, and we want to create a new package called local. And in the local one, we want to create a new test called tasks del test. Short edit, and again, copy paste. So it should use the instant test runner rule, like other del test. And then this small test means it should be part of the small test suite, which is part of the Android test runner annotation. So yeah, the document, the web page will tell you like small test versus medium and large test, and where they are in the testing pyramid. We'll just skip that and continue on the test itself. So we'll create a to-do database, and then we need to initialize an in-memory database. So room in memory database builder, and we just pass in the application context and have a to-do database being created. So of course, with init, we also have to close it after we use it. So after is just close DB, and that should be the whole setup. Now we can actually start writing the test. Is insert task and get by ID. So the test is a run blocking test on the test executor, and we want to create a task. And then import, we want to use the Memcrest comparators, and also is. So what this does is once you insert it, we want to get it back from the task style and verify the things we inserted is the same we just got back. And next up, so this test runs on an emulator. What? So it says it should pass, but cannot. Wow, I didn't run into this when I ran when I ran to this the first time. Let's compare. Hmm. Compare. Of course, it's not there. Okay, so enter test data source local del test. Test get by ID. It is run blocking test. You know what? I don't actually know why this is not happy. Oh, I know why. I screwed up. Uh, the test should be in enter testing. So it should be here. So let me create the right package again. So what I'm going to do is I'm going to cheat, and let me show you what I'm going to do. I'm going to stash all my changes, and then branch check out. I'm going to the solution directly. Oh, because I did finish this before and it was actually working. So in the interest of time, I'm just going to make this hopefully in a working state. So let's go back to the view model test. That's not the view model test, but we want to be in the test del test. So clean project and repeat project. Dun, dun, dun. Life as Android developer is always determined by the speed of how Gradle compiles. So it is running the test on an emulator, and it launches and it's correct. So what was the test? The test was basically inserting and then get and then load. So that's correct. And next up is create another test that is trying to update a task and then insert it. So again, we just say task insert, and then we want to basically update the database with an updated task. So we just say update task. We just create a copy using the copy constructor. Kotlin has this copy constructor that you can just change what you changed as a default parameter, and as a like all the other values will be like passed in as default parameter. You just pass the field that you want updated, and that's the new task. And you insert, and then we'll get the loaded one and check against the updated task, and it should also pass. Let's run it and see. So instrumentation test runs on the device, so it will need to install and then run. The tests itself are fast, but it's like the installation and setup time that's like time consuming. So that's why most people don't like to write instrumentation test. And we also try to avoid it as much as possible for like in my day job. So next up is actually creating a so-called integration test. So we were unit testing the test DAO. Now we want to actually test the integration between the task DAO and the local data source. And so what we want is, again, another file that is created under the same package under Android test and here. And then we want to create the local data source and the actual database. And in our setup, the database, again, is the in-memory settings. And then we want to create the local data source with the local data source using the real database backed by in-memory database. The real DAO, database access object, but it's backed by in-memory instance. So then the setup code is, of course, you also need to clean up the database. And next is writing a test that is, you save a task and then you retrieve one. So the test itself is pretty simple. So you create a new task, and instead of inserting it through the DAO, we insert it through the data source, and then we get the task from the data source, and the same assertion is run. And so let's hope this runs. I mean, it should, because I did it already. And maybe I should just not do live coding anymore. And of course, it runs correctly. So the next step is creating another test. So that is basically, we want to mark a task as complete, and we also want to make sure what we retrieve is also complete. So the step is like creating a new task that have complete equals to false, and then we save it. And then instead of changing the task itself, we want to test the function that is like setting a task to complete by calling complete task using that task object. And then we will just, again, get task and assert like it is containing the right value. In this case, what we really want to test is completed equal to true. It should not be equal to like the value in the new task. So that's the test for here. Next step is end-to-end test with data binding. So we are currently only writing tests that have that are not, how should I say, that are that have no UI basically. So all these are just tests that test the repository layer and below. Now we want to actually test the entire screen. So in step 8 of this collab it first asks you to turn off the animations. So on some of the newer emulators, you actually have to say tap the you actually have to turn on developer options. But I'm using a Marshmallow emulator, so it's just in the developer options, and there should be animation. Let's see here, window animation scale turn off, and transition off, and animator, all of them off. The reason is Espresso is waiting for this screen to waiting for the UI update loop to idle, and if you have animation, it will actually post a lot more events onto that looper, and that's why they want us to turn off the animation. So now it says create a task activity test. So that's actually here on the root package. And again, the test should be annotated with Android JUnit test, and then it's a large test, which in the testing pyramid is like equal to end-to-end task category, which means there should be very few of them, but they should cover like the pretty much important flows that you want to make sure it works all the time. And so we'll basically create a fake task repository, and then we want to have okay, this is for later, and we want to initialize the repository to basically get task repository from the application context, and we'll override the application. Actually, we will not. We'll see. So at first, it will actually like delete everything in the repository, and then call reset repository. And reset repository basically just like replenishes the database with the things that we expect to be there. So first, we will need to write the edit task test. So it started out by creating a title, and then we use this thing called activity scenario here to launch this activity. So if you're writing code with fragments, then you will use fragment scenario. So these are the new testing primitives to help you drive the state of activities. Before we used like activity test rules for this, but it's now replaced by activity scenario because you in this thing, activity scenario provide a lot more functionality and also provide better ways to move between the activity lifecycle. So next up is actually, so the first step is actually writing this and see if it runs before we actually write all the Espresso commands in there. So once that runs, okay, so you probably couldn't see it, but the UI just like open up and close immediately. We can actually say, so this is run blocking, so we can say let it delay for 1 second, and let's run the test again. So I'm minimizing the run window, and hopefully we'll see the UI pop up for a second before it goes away. There you go. The UI showed up for a second. So that means we have the test set up correctly. Now we can actually like start coding with Espresso. So this one is not supposed to be there yet. So basically, you just copy paste from what the description on the website. But what this does is it is looking for a view that has text called title1, and we'll perform a click on it. And once that's done, we'll look for a view with an ID of detailed text and check if it matches title1, and check for description, see if it matches description, and then also check the checkbox state to see if it's not checked. So this is the syntax for Espresso. It can be kind of weird, but once you get used to it, it is kind of like it is quite versatile. And I actually prefer writing in raw Espresso over some other how should I say? There are people building another like layer of the abstraction above Espresso, which I feel it's a bit too much. So, oops. The test failed. Why? Late init property activity has not been initialized. Oh, because of the data binding. So because I changed code already, so it is using data binding, and there are some things that are not initialized. So you see, like the UI just like does thing on its own. That is basically the test is driven by Espresso. So it doesn't have to you won't see any pointer or cursors. It will just like run that way. But that's how Espresso works. It's just finding the thing and tap it. So it just like got out and completed the test. So yes, the test passed. So now as is. So basically, like in this state, if we run the test multiple times, sometimes it fails, sometimes it succeeds. And when I was doing this last time, I was using an API 30 emulator, and I couldn't get it to flake. So the the Colab documentation was telling us like it is flaky because it sometimes succeeds, sometimes fail. So on a newer, higher API emulator, I actually couldn't get it to flake. I actually got it to flake on API 23. So that's why I'm using API 23 emulator. But because I'm already at the end state, so that means we need to basically so I can't reproduce the flakiness, but when you are on this step and doesn't have the data binding yet, then it will actually flake. So you run 5 times, it will flake probably twice or 3 times, not all the time. So flakiness is one of the big problem with Android UI test. And that's why a lot of people avoid them, because it runs locally but fails in your CI, and you can't like merge your code, and that blocks everybody, and that's bad. So it then went on to say we need to introduce something called idling resource, that is telling Espresso to hold off when the UI when the app is busy. So the reason why sometimes it fail is because uh, when it when it say done edit and going to another screen, the database has not yet finished the actions, and Espresso is trying to validate a state that is not yet ready, and that's why it failed. So adding idling resource is a way to say, okay, I am still like reading data or like sending data, and this is not going, please don't try to evaluate the Espresso states. And once the idling resource says, okay, you're good, then Espresso will continue. So the Colab just went on to adding the Espresso idling resource. And so let's see, the data binding idle resource is something that looks like this. And this is basically copy paste from the Colab, so you don't really need to worry about how to come up with idling resource. But basically, it also provides these extension functions for you to use, and that's what we used in the activity test, is to monitor the activity scenario, and that what we use there. And in order for the idle resource to work, we actually have to modify the actual production code. So some people will have like philosophical debates about like the including testing thing in production code, but sometimes it's a necessary evil. So basically, what it does is in the repository, it now wraps everything with like idling resource. So when a function is called in the repository, then idling resource will just say I'm busy. And once the block exits, then the idling resource will become like free, and Espresso will continue. So basically, you'll just have to follow the collab and then modify the repository, and then use that idling resource in your test by saying declaring this, and then register the idling resource with Espresso in before, and unregister it in after, because you don't want your idle resource to pollute other tests. So you definitely want to unregister. Yeah, so that is the task activity test. So once you are done with edit task, then it asks you to write another task, that is create one task and delete a task. So it's basically doing all the clicks in the UI and then check if a new item shows up and tap into it, and then in the three dot menu tap delete. And so that's the test, and we can run it. But it also have links to like the completed collab. So I think that's pretty straightforward. Um, so you create a new task, done, and then yeah, hit the trash can and hit that thingy. So that's the test, and that's how it runs. So finally, we're on to step 9, which is actually the last step in the collab. Sorry about my overtime. Thank you for sticking around. And we'll basically be creating a thing called navigation test or app navigation test. That is this one. So remember back in the first collab, we were first StudyJam, we were actually talking about the navigation. And so this one is actually using a navigation to test, like how we navigate in the app. So again, they provided basically the necessary skeleton of the repository, setting it up, and then reset the repository, and then registering the idling resource and then registering it. So now you actually have to like set up your test. So first is, of course, creating the activity scenario to launch the root task of this app, which is the task activity. And we need to check like the so what I want to say is check the drawer to see if it's closed, and then see if we can get the content description from activity scenario, and just tap on that, and then see if we open the drawer and then we close the activity. So this is not part of the navigation, but I guess. So next one is testing for the detail up button. So this one is more interesting because you are going to say we are creating a new task and finding it on screen. Tap on it, and then you should have edit button, and then you can hit the back on the screen to like go back to the main screen. And again, it's using the toolbar navigation content description from activity scenario. And that one is for just finding the up button, which can be, let's see, let's run the app and just see it there. Where is the to do here? So this 3 dot or the hamburger is actually the up button in the taskbar. So that's what like this thing is trying to get. So in this case, it will actually be this button. So this is applicable if you use the toolbar control. And so that's what this test is. And then the third test is actually using pressback. So what is this? So in the previous task, it is like navigating by hitting things in your UI. But in this test, it is actually testing if we can navigate using the back button, the software back button. So that's why here press back is called. One thing to notice is if when I was writing this test, I was running into a strange error. So let me remove this import and try to import a different one. So there are two of them. One is in view action, and one of them is in Espresso. If you use the view action one, the test will actually fail. So let's see. The reason why it fails is because it couldn't navigate back. And so Espresso well, one of the things that people scared of Espresso is the error message that it emits. It actually dumps the entire screen out and tell you like, I can't find a view that matches the things that you're looking for. Um, so it takes a bit to read through. Sometimes it will actually tell you what is the closest match. Sometimes it's the state that doesn't match, and in that case, it will actually tell you what the view it find and that is closest, so you can look at that error message. But in this case, it's basically stuck in a different screen, so it couldn't find anything that it wants to find. And the reason is I used the wrong import. So this view action dot press back doesn't seem to give me the right behavior of pressing back. And so changing that import to the Espresso dot press back makes the collab work because it actually sends the back button instead of finding a back view or something like that. So now it's running and passes. And that is all the tests that you'll write in this collab. And I will stop showing Ender Studio and let me share back the UI, the web page. So here on step 10, it will basically point you to the GitHub location. And then it also points you to more advanced and more complete tests that you can find in architecture blueprint sample. And so summary, well, we wrote tests using run blocking and run blocking test. And we use test coroutine dispatcher that have pause and resume functionality. And we also added Espresso end-to-end test to basically test your app as it's running and use idling resource to reduce flakiness. And also we wrote test to test the navigation. So that's it, folks. To learn more, a lot more to learn, and that's it. This next collab link is actually going back to a page that will not take you to where you were. So that's probably a bug on the Ender team. But with that, I'm going to stop recording and thank you for joining me on this strange journey.